Hello students, welcome to this lecture One Real Numbers. So in this lecture, we'll discuss exercise 1.1 from ncert class 10 maths book. Okay, and then we'll discuss more examples, more problems. Okay, so let's get started. So before starting, here first we'll discuss which types of questions may will ask in your question paper. Okay, so in your question paper may ask in your question paper definition based questions on this chapter. For example, defining rational number, irrational numbers, prime numbers, composite numbers, and etc. Or second type of questions may be asked in your question paper, theoretical explanation, such as explaining the fundamental theorem of arithmetic, Euclid's division lemma, or the process of the finding HCF and LCM. And third type of questions may be asked in your question paper, proving numbers to be rational or irrational. For instance, proving root 2, root 3, or the sum or product of rational and irrational number is rational or irrational number. Okay, so let's get started. Exercise 1.1, question number 1. So this is the question number 1. So in question number 1, here we have to express each number as a product of its prime factors. Okay, so first one we have 140. Okay, so 140, this can be written as 140. So you can write this as 2 and 70. Okay, so the divisors of 140 are 2 and 70, and the divisors of 70 are prime divisors of 70 are 2. The divisors of 70 are 2 and 35, and the divisors of 35 are 5 and 7. Okay, so 140, this number can be factorized or expressed in as a product of prime factors as 2 into 2 into 5 into 7. Okay, and this is equal to 2 square into 5 into 7. Okay, and second number is 156. So 156, you can find it divisors, 2 and 78. Okay, and then 78, it has 2 divisors, 2 and 30. The divisors are 2, 3, 9, 39. Okay, and the divisors of 39 are 3 and 30. Okay, so 156, this number can be factorized as 2 into 2 into 3 into 13, that is equal to 2 square into 3 into 30. Okay, so in this manner you can find the factorization of 3825. Okay, so 3825, this is equal to 3 into 3 into 5 into 5 into 70, and this is equal to 3 square into 5 square into 70. Okay, and fourth question we have 5005. So 5005, this can be expressed as 5 into 7 into 11 into 30. Okay, so this is the prime factorization of 5005. And next one we have 7429. So 7429 is basically the product of 17, 19 and 23. Okay, so this is the prime factorization of 7429. Okay, so we here express each number as a product of its prime factors. Okay, so in question number 2, find the LCM and HCF of the following pairs of integers. Okay, and we have to verify that LCM into HCF, this is equal to product of two numbers. Okay, so in first number we have two positive integers, 26 and 91. Okay, so we can use prime factorization method for finding LCM and HCF of the following pairs of positive integers. Okay, so for first one, the prime factorization of 26 is basically 2 into 13. Okay, so 2 into 13 is the prime factorization of 26, and the prime factorization of 91 is 7 into 13. 7 into 13. Okay, so here the common prime factors. Okay, common prime factor is 13, and the lowest power of common prime factors is 13 to the power 1. Okay, so HCF of 26 comma 91, this is equal to 13. Okay, and here the prime factors 2, 13, 7. Okay, the highest power of 2, 13, 7 are actually they themselves. Okay, itself. So 2 to the power 1, 13 to the power 1, and 7 to the power 1. Okay, so the LCM of 26 comma 91, this is equal to 2 into 7 into 13, and this is basically equal to 182. Okay, so the HCF of 26 comma 91 is equal to 13, and the LCM of 26 and 96 is equal to 182. Okay, now if we take product 26 and 91, so product of two numbers 26 into 91, this is equal to 2366. Okay, and if we multiply HCF of 26 comma 91 and LCM of 26 comma 91, then it is equal to 13 into 182, and if we calculate it, then we'll get this is equal to obviously 2366. That is actually equal to the product of two numbers. Okay, so hence here verified product of two numbers is equal to HCF of two numbers into LCM of two numbers. Okay, so for next we have these two positive integers 510 and 92. Okay, so first of all we have to find HCF of 510 and 92 and the LCM of 510 and 92. Okay, so our first task is factorize 510 and 92. Okay, so if we factorize 510 as a product of prime factors, then we'll get 510, this is equal to 2 into 3 into 5 into 17. Okay, and if we factorize 92 as a product of prime factors, then we'll get this is equal to 2 into 2 into 23. Okay, so here the common factors in both numbers are actually is 2. Okay, so here the common factors is 2, and the lowest power of common factor is also 2 to the power 1. Okay, so HCF of 510 and 92, this is equal to 2. Okay, HCF of 510 and 92 is equal to 2. And here the prime factors 2 has highest power 2. Okay, so 2 square into the prime factor 3, the highest power actually 3 to the power 1 into the prime factors 5, highest power is 5 to the power 1. Okay, into 17 into 23. Okay, so the LCM of 510 comma 92, this is equal to 2 square into 3 into 5 into 17 into 23. Okay, and this is equal to 23460. Now you have to verify the product of two numbers. This is equal to HCF of two numbers into LCM of two numbers. Okay, so here product of two numbers, this is equal to 510 times 92. Okay, and this is equal to 46920. Okay, and here HCF of two numbers 510 and 92 into LCM of 510 into comma 92, this is equal to 2 times 23460. Okay, and this is equal to 46920. So hence the product of two numbers, this is equal to HCF into LCM. So verified. So verified product of two numbers, this is equal to LCM of two numbers into HCF of two numbers. Okay, So in next one we have this pair of positive integers 336 and 5 to the 5 554. Okay, 336 and 54. So the prime factorization of 336 is basically 2 into 2 into 2 into 2 into 3 into 7. Okay, that is basically 2 to the power 4 into 3 into 7. Okay, and the prime factorization of 54 is 2 into 3 into 3 into 3. Okay, and this is basically equal to 2 into 3 to the power 3. Okay, so here the common factors are 2 and 3, 2 and 3 in both numbers. Okay, and the lowest power of the common factors is 2 to the power 1 and 3 to the power 1. Okay, so the HCF of 3, 3, 6 and 54 is equal to 2 into 3, that is equal to 6. Okay, and the LCM of 336 and 54, this is equal to the product of highest power of the prime factors in both numbers. Okay, so here the prime factors 2, the highest power of the prime factor 2 is 2 to the power 4. Okay, and the highest power of the prime factor 3 is 3 to the power 3, and the highest power of the prime factor 7 is 7 to the power 1. Okay, so the LCM of 336 comma 54, this is equal to 2 to the power 4 into 3 to the power 3 into 7, and this is equal to 3024. Okay, so now the product of two numbers 336 and 54, this is equal to 18144. Okay, so now if we take the product HCF into LCM, this is equal to 6 into 3024. Okay, and this is equal to 18144. So hence the product of two numbers, this is equal to HCF into LCM. Okay, so in next question here we have to find the LCM and HCF of the following integers by applying prime factorization method. Okay, so in this question basically we have given three numbers. Okay, and for these three numbers we have to find LCM and HCF. Okay, so in first one we have given 12, 15 and 21. In second one we have given 17, 23 and 29, and third one we have given 8, 9 and 25. Okay, so let us see how to find LCM and HCF of these following integers. Okay, so in first one we have 12, 15 and 21. Okay, the first we have factorized 12. So if we factorize 12, then 12 this is equal to 12, this is equal to 2 square into 3. Okay, and if we factorize 15, then 15 is equal to basically 3 into 5, and the factorization of 21, this is equal to 3 into 7. Okay, so here the common factors, the lowest power of the common factors is basically 3. Okay, so HCF of 12, 15 and 21, this is equal to 3. Okay, and then the LCM of 12, 15, 21. So this is equal to the product of highest power of the factors, prime factors in the numbers. Okay, so here the prime factors 2, the highest power is 2. Okay, so 2 is square into the prime factors 3, the highest power is 1, so into 3 into the prime factors 5 to the power 1 into prime factors 7 to the power 1. Okay, so the LCM of 12, 15, 21, this is equal to 2 to the power 2 into 3 into 5 into 7, and this is equal to 420. Okay, so now in next question here we have given these following integers 17, 23 and 29. Okay, so the factorization of 17 is basically 1 into 17. Okay, and the prime factors of 23, that is basically 23. Okay, 1 into 23. 29 is 1 into 29. So here basically common factors is 1. Okay, so the HCF of 17, 23, 29, is equal to 1. Okay, and here the LCM is basically product of these three numbers. Okay, so LCM of 17, 23, 29, this is equal to 17 into 23 into 29, and this is equal to 11339. Okay, so this is the LCM and this is the HCF of these three numbers. Okay, and next we have 8, 9 and 25. Okay, so the prime factorization of 8 is basically 2 into 2 into 2. Okay, and the prime factorization of 9 is 3 into 3, and the prime factorization of 25 is 5 into 5. Okay, so here you can see there is no common prime factors between 8, 9 and 25. So the HCF of 8, 9, 25 is equal to 1. Okay, so HCF of 8, 9, 25 is equal to 1. And then the LCM, this is equal to the product of highest power of the prime factors in numbers. Okay, so LCM here, here the highest prime factors of 2 is 2 to the power 2, 2 to the power 3. Okay, so the highest power of the prime factor 2 is 2 to the power 3. The highest power of the prime factor 3 is 3 to the power 2, and the highest prime factors of 5 is 5 square. So LCM, this is equal to basically 2 square in 2 cube into 3 square into 5 square, and that is equal to 1800. Okay, 1800. And next problem. So in next question, here I have given HCF of 306, 657 is equal to 9. Okay, so we have given HCF, and here we have to find LCM of 306 and 657. Okay, so what we know product of two numbers, this is equal to HCF of two numbers into LCM of two numbers. Okay, so if we use this result, then we can easily find LCM of these two numbers. Okay, so here HCF is given by 9. Okay, so HCF of 306, 657 is equal to 9. Okay, and we know that LCM into HCF, this is equal to product of two numbers. Okay, so LCM into HCF, this is equal to product of two numbers, and therefore LCM into HCF, this is equal to 306 into 657. Okay, so here we have given the HCF of 306, 657 is equal to 9. Okay, so now the LCM, this is equal to 306 into 657 divided by HCF, that is 9. Okay, so 306 into 657 divided by 9, and if we calculate it, then we will get the LCM of 306, 657 is equal to 22338. Okay, so its LCM is 22338. So now let us move to next question. So here check whether 6 to the power n can end with the digit 0 for any natural number n. Okay, so here if any number ends with the digit 0, so it should be divisible by 10. In other words, it will also be divisible by 2 and 5, as 10 can be factorized as 2 into 5. Okay, so the prime factorization of 6 to the power n, this is basically equal to 2 into 3 whole to the power n. Okay, and it can be observed that 5 is not a prime factorization of 6 to the power n. Okay, so by the uniqueness of fundamental theorem of arithmetic, we can say there is no natural number n for which 6 to the power n will end with 0. Okay, there is no natural number for which 6 to the power n will end with 0. Okay, now explain why this and this are composite numbers. Okay, so explain here. So we know what does mean by composite numbers. Okay, so composite numbers is a number which has divisors other than 1 and itself. Okay, actually composite numbers, in other words, besides divisible by 1 and itself, the composite numbers have more than one divisors. Okay, more than other one divisors. So here, this number 7 into 11 into 13 plus 13. Okay, so here we explain why this is a composite number. Okay, so numbers of two types we know, prime and composite. So prime numbers can be divided by 1 and only itself, whereas composite numbers have factors other than 1 and itself. Okay, so here it can be observed that 7 into 11 into 13 plus 13, this is equal to, actually here 13 number is common in both two numbers, so here we can common out. So this is equal to 13 into 7 into 11 plus 1. Okay, and this is equal to 13 into 77 plus 1. Okay, this is equal to 13 into 77 plus 1. Okay, and this is equal to 13 into 78, and this is equal to 13 into 13 into 6. Okay, so for this number here, 6 and 13 are the prime factors which will divide this number. Okay, so here for this number have factors other than 1 and itself. Okay, so this number 7 into 11 into 13 plus 13, this number is a composite number. Okay, and now for second one, the given expression has, so for second one, 7 into 6 into 5 into 4 into 3 into 2 into 1 in 1 plus 5. Okay, so here 5 and 5 is common in both. Okay, so here we can common out 5. Okay, so this is equal to 5 into 7 into 6 into 4 into 3 into 2 into 1 plus 1. Okay, and if we product these numbers, then this is equal to 5 into 1008 plus 1. Okay, and this is equal to 5 into 1009. Okay, so for this number here 1009 cannot be factorized further. Okay, therefore the given expression has 5 and 1009 as its factors. Okay, so hence it is a composite number. Since this number other than 1 and itself have two other composite or two other prime factors, 5 and 1009. Okay, two other divisors. Okay, 5 and 1009. So that this number is not a composite number. Okay. So in question number 7, there is a circular path around a sports field, and Sonia takes 18 minutes to drive one round of the field. Okay, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. So after how many minutes will they meet again at the starting point? Okay, so basically we have here a circular path around a sports field, and here Sonia takes 18 minutes to drive one round for the field, and while Ravi takes 12 minutes for the same. Okay, and suppose they both start at the same point and at the same time and go in the same direction. Okay, so they start same point, same time, at the same time and go in the same direction. So after how many minutes will they meet again at the starting point? Okay, so it can be observed that Ravi takes lesser time than Sonia for completing one round of the circular path. Okay, so as they are going in the same direction, they will meet again at the same time when Ravi will have completed one round of that circular path with respect to Sonia. Okay, and the total time taken for completing this on round of circular path will be the LCM of time taken of Sonia by Sonia and Ravi for completing one round of the circular path respectively. Okay, that is LCM of 18 minutes and 12 minutes. Okay, so total time taken for completing this one round of the circular path will be the LCM of time taken by the Sonia and Ravi for completing one round of the circular path. Okay, so basically for getting answer here we have to find the LCM of 18 and 12. Okay, so we can now factorize 18 as 2 into 3 into 3, that is 2 into 3 square. Okay, and we can factorize 12 as 2 into 2 into 3, that is equal to 2 square into 3. Okay, and here the prime factors are 2 and 3. Okay, and the highest power of the prime factors 2 is 2 square. Okay, so 2. So LCM of 18 comma 12, this is equal to 2 square into the highest power of the prime factors 3 is 2. Okay, so into 3 square, this is equal to 4 into 9 and this is equal to 36. Okay, so LCM of 18 comma 12, this is equal to 36. Okay, so therefore Ravi and Saniha will meet together at the starting point after 36 minutes. Okay, so after 36 minutes they will meet together at the starting point. Okay, and here problem find the HCF and LCF of 24 and 36 and verify HCF into LCM, this is equal to product of two numbers. So prime factorization, problem 2, express 560 as a product of its prime factors and find the prime factorization of 560. Okay, so this is our problem 1. This is okay, this problem 2 is prime factorization method. Okay, so we have express 560 as a product of prime factors. Okay, and find the prime factorization of 560. And then next one, application problems on LCM and HCF. So two traffic lights at two different roads change after every 48 seconds and 72 seconds respectively. If they change simultaneously at 8 a.m., at what time will they change simultaneously again? Okay, so problem 1, solution. HCF of 24 and 36, find the largest number of the divides both 24 and 36 without any remainder, that is HCF is 12. So in 24 can be factorized as 2 to the power 3 into 3, and 36 can factorize as 2 square into 2 square into 3 square. Okay, so here the LCM HCF, so HCF of 24 comma 36, this is equal to the common prime factors, lowest common factor, product of lowest common prime factors, that is 2 square into 3 and this is equal to 12. Okay, so HCF is 12. And LCM of 24 and 36. So here the smallest common multiple of 24 and 36. So here the highest LCM of 24 comma 36. This is equal to highest product of highest power of the prime factors. That is here 2 to the power 3 into 3 square. This is equal to 72. Okay, so the LCM of 24 comma 36 is equal to 72. And here you can verify HCF into LCM, this is equal to 12 into 72 and this is equal to 864, which is equal to 24 into 36 is equal to 864. Okay, and for problem 2 solution, the prime factors of 560, this is equal to 2 to the power 4 into 5 into 7. Okay, and for problem 3 solution 3, find the LCM of 48 and 72 to determine the interval at which they change simultaneously. So LCM of 48 and 72 is equal to 144 second. Okay, so 144 second, that is actually 2 minutes 24 second. Okay, so therefore after 8 a.m. they will change simultaneously again after 144 seconds, which is 2 minutes 24 seconds. So they will change simultaneously again 8 hours 2 minutes 24 second a.m. Okay, so I stop here this lecture. Thank you very much to all of you.